On February 13, 1942, Fleet Admiral Chester Nimitz stood on the pier at Pearl Harbor, watching something most considered impossible. The battleship Nevada, her hull wrapped in massive wooden patches that made her look like a wounded giant in bandages, rose slowly from the harbour bottom where she had lain for over 2 months. The water streaming from her decks carried oil, debris, and the bitter memory of December 7th. Behind Nimitz, the twisted wreckage of Arizona served as a reminder that not every ship could be saved. But Nevada's salvage was proving something crucial to America's war effort. The Pacific Fleet wasn't finished. It was coming back to life through an engineering miracle orchestrated by divers, welders, and shipyard workers who refused to accept defeat. The scope of devastation on December 7th had seemed insurmountable. 8 battleships struck, 5 sunk or sinking, over 2,400 Americans dead. Nevada had been the only battleship to get underway during the attack, her crew desperately trying to escape the harbour. Japanese dive bombers spotted her moving and concentrated their fury on the vessel attempting escape. 5 bomb hits and 1 torpedo later, Captain Scanland ordered Nevada beached at Hospital Point to prevent her from blocking the critical channel. She settled there, her bow submerged, stern barely above water, fuel oil bleeding into the harbour from ruptured tanks. By Monday night, her increasing weight pulled her stern off the coral reef. She sank completely, joining California and West Virginia on the harbour bottom. Pearl Harbor Navy Yard had never faced a salvage challenge of this magnitude. Captain Homer Wallin, appointed to oversee salvage operations, confronted a problem that seemed beyond solution. 3 battleships resting on the bottom, their hulls torn by torpedoes and bombs, interiors flooded with thousands of tons of water mixed with fuel oil. Conventional salvage wisdom suggested these vessels were total losses. Wallin thought otherwise. He assembled teams of Navy divers and civilian workers from Pacific Bridge Company, issued them cutting torches and pumps, and told them to bring back the fleet. Nevada became the first priority. She lay in relatively shallow water with damage that, while extensive, appeared manageable compared to California and West Virginia. The torpedo hit on her port side between the forward turrets had created a hole approximately 30 feet wide. Bomb hits had opened smaller breaches throughout her hull. The salvage plan called for patching every opening, installing massive pumps, and raising the ship through controlled dewatering. Simple in concept, extraordinarily difficult in execution. Divers working on Nevada faced conditions beyond normal salvage operations. The interior spaces flooded with seawater contaminated by fuel oil created a toxic environment. Visibility underwater approached zero. Divers worked by touch, feeling their way through twisted compartments filled with debris and unexploded ordnance. The December Hawaiian heat turned submerged spaces into fermenting tanks, where provisions rotted and generated hydrogen sulfide gas. 2 divers died in early February when they encountered lethal concentrations of this invisible killer. Their deaths underscored the danger facing every man who descended into the sunken battleships. The Pearl Harbor Navy Yard fabricated 2 types of patches for Nevada. Small window frame patches covered bomb damage, bolted directly to the hull with rubber gaskets providing watertight seals. These worked effectively for holes up to 6 feet across. The main torpedo damage required something far more ambitious. Yard workers constructed a massive curved wooden patch, 60 feet long and 40 feet high, designed to cover the entire portside torpedo hole. This big patch, as workers called it, represented an engineering gamble. If it sealed properly, Nevada would rise. If it failed during pumping operations, the ship would flood catastrophically and possibly sink beyond recovery. Installation began in mid-January. Divers secured the enormous wooden structure to Nevada's hull using hundreds of bolts drilled through the patch and into the ship's frames. Pudding, canvas bags filled with oakum and pitch, provided gasket material between patch and hull. The work required over 400 dives totaling more than 1,500 underwater hours. Every bolt had to be secured by divers working in darkness, their air hoses constantly threatened by sharp metal edges. Pacific Bridge Company's 6 divers worked rotations around the clock, surfacing exhausted after hours in contaminated water. While divers patched the exterior, other teams worked inside Nevada. Every port, every hatch, every ventilation duct had to be sealed. Pumps couldn't overcome inflow if hundreds of small openings allowed water to return faster than pumping could remove it. Workers drove wooden wedges into ruptured piping, sealed sanitary drains, and closed gun ports with strongbacks and custom-fitted covers. The ship had to become a sealed container before pumping could succeed. By early February, preparations reached completion. Dozens of pumps positioned throughout the ship stood ready to remove thousands of tons of water. The critical question remained whether the big patch would hold under the tremendous pressure differential as water inside dropped below the level outside. On February 10th, pumping began. Water slowly receded from interior spaces, revealing conditions worse than anticipated. Compartments contained not just water and oil, but decomposing food, personal effects from the crew, and the heartbreaking debris of men who died fighting their ship. Cleanup teams worked in gas masks, removing material that had fermented in tropical heat for over 2 months. Several workers required medical treatment for hydrogen sulfide exposure. The big patch held, but barely. As interior water dropped, the wooden structure creaked and groaned under increasing pressure. Divers monitored constantly, ready to report any failure. Pumping continued day and night. On February 13th, Nevada stirred. Her hull shifted, breaking free from the mud suction holding her to the bottom. Slowly, almost imperceptibly at first, she began rising. Workers on deck felt the movement and cheered. The impossible was happening. Nevada was coming back from the dead. Floating Nevada to dry dock presented new challenges. The big patch, stressed beyond its design limits, couldn't withstand movement through the harbour. Naval architects calculated that any significant wave action might collapse the patch and sink the ship mid-channel. The solution was audacious. Tugboats positioned Nevada mid-channel, then divers descended and removed the big patch entirely. For several hours, Nevada floated with a 30-foot hole in her port side, prevented from sinking only by carefully balanced buoyancy and constant pumping. Additional tugs stood ready to beach the ship instantly if flooding became uncontrollable. On February 18th, Nevada entered dry dock number 2. Admiral Nimitz attended, understanding this moment's significance. As the dock gates closed and water pumped out, revealing Nevada's battered hull standing on blocks, the entire harbour seemed to exhale. The first of Pearl Harbor's sunken battleships had been recovered. Tennessee, Maryland, and Pennsylvania, damaged but not sunk, had already returned to service. Nevada's successful salvage proved the sunken battleships could follow. The Pacific Fleet was recovering. Nevada's success established procedures for the far more difficult salvages ahead. California presented unique challenges. She had settled into mud so soft it approached quicksand consistency. Her hull was stuck fast, held by suction that conventional pumping couldn't overcome. Worse, California's turbo-electric drive system, advanced technology using electric motors to turn the propellers, had been submerged in salt water for months. Engineers worried the entire propulsion system might be destroyed beyond repair. California's salvage began simultaneously with Nevada's in January, but employed different techniques. Instead of a single massive patch, engineers designed multiple smaller cofferdams around each torpedo hit. These wooden structures, built with heavy timber and braced with steel, created watertight boxes around damaged areas. The plan called for pumping out the cofferdams, then filling larger breaches with concrete that could set underwater. This approach distributed the salvage effort across multiple work sites, requiring more divers but reducing the risk of catastrophic single-point failure. Pacific Bridge Company workers constructed cofferdams from massive timbers, some exceeding 2 feet square. These structures had to withstand water pressure while remaining watertight as interior water levels dropped. Pudding filled gaps between cofferdam and hull. As pumping progressed, divers descended inside the cofferdams to seal leaks that appeared under pressure. The work was claustrophobic and dangerous, performed in confined spaces where a single air hose rupture meant certain death. Manpower shortages plagued California's salvage. Experienced crew members were constantly reassigned to other vessels desperately needed for operations. Replacement sailors arrived unfamiliar with the ship's complex systems. Training them while conducting salvage operations slowed progress. The Navy decided experienced personnel were needed fighting rather than salvaging, accepting delays as unavoidable. Interior cleanup on California revealed the attack's human cost. Nearly 50 crew members' remains were recovered from flooded compartments. Pumping deliberately slowed to allow respectful recovery operations. Every body received proper military honours before salvage work continued. These grim discoveries reminded workers that battleships weren't just steel, but homes for thousands of sailors who died defending them. By late March, California began responding to salvage efforts. Her hull shifted slightly, indicating she might break free from the mud prison. On March 29th, after intensive pumping that removed hundreds of thousands of gallons, California lurched upward. The suction broke. She floated free, her cofferdams holding, pumps maintaining control over inflow. Unlike Nevada's dramatic rise, California's recovery was gradual and methodical, but by early April she was ready for dry dock. Dry dock availability delayed California's entry. The aircraft carrier Lexington occupied Dry Dock No. 2, receiving battle damage repairs. Naval priorities dictated carriers took precedence over battleships. California waited, her cofferdams holding, crews maintaining pumps around the clock. On April 9th, she finally entered dry dock, the second battleship successfully salvaged. Her turbo-electric drive, surprisingly, had survived submersion. Proper flushing and maintenance would restore functionality. West Virginia represented the most severe salvage challenge. The battleship had absorbed at least 7 torpedoes on her port side, creating damage one observer described as looking like an angry creature with explosives had clawed through the hull. An entire midship section was simply gone, the armoured belt twisted, frames shattered, plating torn away in massive irregular gaps. Conventional patching couldn't seal damage this extensive. Engineers needed a completely different approach. The solution exploited West Virginia's intact 13-inch armoured belt. This heavy armour, designed to resist battleship shells, provided mounting points for an elaborate composite patch system. Engineers designed multiple interconnected sections made of wood, steel and concrete that would be joined together outside the hull, then sealed with underwater concrete. The intact armour belt would support the structure, transferring the enormous pressure loads into the strongest part of the ship. Installation began in January with placement of vertical H-beams bolted to the armoured belt every 8 feet. These beams provided a framework to which the composite patches could be attached. Each patch section weighed several tons and required precise positioning by divers working outside and inside the hull simultaneously. The sections had to align perfectly, with concrete sealant filling gaps to create a watertight barrier. Unlike Nevada's big patch or California's timber cofferdams, West Virginia's solution used modern materials in an innovative combination that had never been attempted. Tragedy marked West Virginia's salvage in ways that haunted every worker. In January, divers making early inspection passes heard faint tapping sounds from inside the hull. The tapping came from compartments deep within the ship, areas flooded immediately after the attack. Salvage teams worked frantically to reach the source, but the complexity of accessing flooded interior spaces through twisted wreckage prevented immediate rescue. The tapping gradually weakened, then stopped. When those compartments were finally opened months later, calendar records found with the victims showed some crew members had survived in air pockets for 16 days after the attack, marking off each day before oxygen ran out. They had been alive, tapping desperately for help that couldn't reach them in time. This knowledge devastated salvage workers who had heard those sounds and been unable to help. West Virginia's size and damage extent required removing weight before raising could succeed. Salvage teams pumped out 800,000 gallons of fuel oil, removed 16-inch gun projectiles and powder charges, and extracted 70 tons of rotting provisions. Every reduction in weight increased the margin for successful raising. Gun turrets were rotated to create deck space for pump placement. Unlike Nevada and California, West Virginia's pumping strategy involved opening hatches to flush hydrogen sulfide contaminated water, accepting slower progress in exchange for worker safety after multiple gas exposure incidents. The composite patch system worked brilliantly. As pumping progressed through April and early May, the interconnected sections held firm. 650 tons of underwater concrete sealed the bottom edges, creating a watertight barrier that exceeded engineering predictions. West Virginia's hull responded to the controlled dewatering. On May 17, 1942, she broke free from the bottom. Workers watching from shore witnessed the most damaged battleship slowly rising, her massive hull emerging like a wounded whale returning to the surface. The composite patches, streaked with concrete and barnacles, looked improvised and crude. But they worked. Dry dock access again required waiting. The Battle of Midway in early June damaged the carrier Yorktown and required emergency dry dock space. Carriers still took priority. West Virginia waited through May and early June, her patches holding, crews maintaining the delicate balance keeping her afloat. After Midway's conclusion and damaged carriers received attention, West Virginia entered Dry Dock No. 1 on June 9th. The spectacle of her entering dry dock drew hundreds of workers who understood the achievement. The most heavily damaged battleship salvaged anywhere during the war was now in the shipyard's hands for repair. Throughout these operations, salvage teams worked parallel efforts on other vessels. The battleship Oklahoma, capsized with her bottom exposed, required a completely different approach, using massive winches and cables. The elderly battleship Utah, capsized on the opposite side of Ford Island, posed similar challenges. Destroyers Cassin, Downs, and Shaw, all damaged severely, received attention as resources permitted. The mine layer Oglala, sunk at her pier, was refloated relatively easily. Each vessel required specialized techniques, but the 3 battleship salvages represented the most critical efforts. The success of these operations owed much to American industrial capacity. Pearl Harbor Navy Yard manufactured patches, cofferdams, pumps, and specialized equipment at rates that would have been impossible for smaller facilities. The yard's machine shops worked 24 hours daily, producing parts for multiple simultaneous salvage operations. Timber for cofferdams arrived from the mainland in massive quantities. Concrete, steel, welding equipment, diving gear, and hundreds of other materials flowed through supply chains that connected Pearl Harbor to America's industrial heartland. This logistical achievement paralleled the technical accomplishments. The human cost of salvage operations extended beyond the 2 divers who died from gas exposure on Nevada. Multiple workers suffered injuries from falls, equipment failures, and exposure to toxic materials. Diving in contaminated water caused skin conditions and respiratory problems. The psychological toll of recovering remains while working in spaces where men died fighting was immense. Yet the salvage teams persevered, motivated by determination to restore the fleet and by competition. Captain Wallin's messages to workers characterized their effort as competing with the industrious Japanese, framing salvage as an extension of the war effort rather than merely repair work. By mid-June 1942, all 3 battleships floated in dry docks or repair basins. Nevada proceeded to repair facilities where her battle damage would be addressed and modernization work begun. California entered extensive repair that would last through 1943. West Virginia faced the longest repair period, requiring reconstruction of her entire midship section. All 3 battleships would eventually return to combat, participating in the island-hopping campaigns that drove across the Pacific toward Japan. The salvage operations at Pearl Harbor demonstrated engineering resourcefulness, industrial capacity, and human determination that characterized America's approach to World War II. Ships declared total losses by conventional wisdom returned to service through innovative techniques and relentless effort. The operations established salvage procedures used throughout the war and influenced post-war naval engineering. Modern salvage operations still reference Pearl Harbor techniques when addressing similar challenges. The battleships raised from Pearl Harbor's bottom carried symbolic importance exceeding their military value. Each ship refloated represented defiance of the December 7th attack. Each successful salvage proved American industrial might and technical skill could overcome catastrophic damage. The Japanese attack had been tactically successful, but strategically incomplete. It failed to destroy repair facilities, fuel storage, or the aircraft carriers. Most crucially, it failed to sink ships beyond recovery. Captain Wallin and his salvage teams exploited that failure, bringing back a fleet that would help carry the war across the Pacific to Japan's doorstep. 3 battleships rose from Pearl Harbor's bottom through human courage and engineering brilliance. Their salvage remains one of history's most remarkable naval engineering achievements, accomplished under wartime pressure with improvised techniques and incomplete information. The divers who descended into toxic darkness, the workers who fabricated enormous patches, the engineers who designed solutions to unprecedented problems, all contributed to a miracle of determination. They proved that some defeats are temporary, some losses recoverable, and some ships too valuable to abandon. Nevada, California, and West Virginia rose because Americans refused to accept their loss. That refusal, that determination to fight back from disaster, characterized the entire American war effort. The salvage of Pearl Harbor showed the world that America would not be defeated by a single blow, no matter how devastating. The fleet would return stronger than before, carried forward by the same determination that raised 3 battleships from the bottom of Pearl Harbor.